Good morning, guys. Today we will be discussing about understanding structural and data dependence and data redundancy and anomaly. Now, for our lecture, we will try to answer the following questions. The first one is, how do we define structural and data dependence? Next, when does data redundancy occur? And lastly, when does data anomaly occur? Now, for our intended learning outcomes, we should be able to learn the importance of structural and data independence, as well as know what is data redundancy and data anomaly and how it should be avoided at the end of the lesson. Now, when we say dependence, what does come into your mind? The word dependence tells us that one characteristic or one object relies on another characteristic or another object for it to function or operate properly. So that is the meaning of the word dependence. An analogy for this is, let's say for example, you as a student is dependent on your parents or guardian for your allowance. Another is that a baby is dependent on his or her mother in order for him or her to feed or to live. Okay, so that is the meaning of the word dependence. Now, we have two types of dependence. We have structural and data dependence. Now, when we say structural dependence, a file system exhibits structural dependence, meaning that access to a file is dependent on its structure. Take note, we can only access the file depending on the file structure. That is structural dependence, meaning we may not be able to access a certain file based on how it is constructed or created. So that is structural dependence. Now, the reverse of structural dependence is structural independence. Structural independence exists when it is possible to make changes in the file structure without affecting the application program's ability to access the data. So in structural dependence, the files can only be accessible depending on the file structure, whereas in structural independence, it is possible to change the file structure, okay, without affecting the ability to what? To access that particular data. Okay. So in structural dependency, we are talking about the file structure. Okay. Now we have another instance. This is called data dependence. So when all data access programs are subject to change when any of the file's data storage characteristic change, that is changing the data type, the file system is said to exhibit data dependence. Now, with regards to data dependence, we are now talking about the file's data storage characteristics. So particularly the data type, string, number, date, boolean, okay? We can only access the data inside the file depending on the data storage characteristics or depending on the changes of the data storage characteristics. That is data dependence. Now, the reverse of data dependence is data independence, wherein it is possible to make changes in the data storage characteristics without affecting the application program's ability to access the data. Okay, to summarize, structural dependence, we can only access the file Okay, depending on its structure, structural independence, we can make changes to the file structure without affecting access to the file or to the actual data inside the file. Data dependence, so data access is dependent on the data storage characteristic. And data independence, it is possible to make changes to the data storage characteristic without affecting the application program's ability to access the data. The practical significance of data dependence is the difference between the logical data format and the physical data format. Now, let me explain. When we say logical data format, okay, basically it is how the human beings view the data. It is how we see the data. So how do you usually see the data? It is usually in form of tables. Like for example, we can look at an Excel file. Okay, there are data written on it. That is the logical data format. Okay, usually it is in tabular form, or for example, if you open up an XML file, there are hierarchy of data there. Or for example, we open up a CSV file. Okay, a CSV file is just like a text file, which is separated by comma. Okay, that is the logical data format. How we view or how we see the data. Now, when we say physical data format, this is how the computer must work with the data. Basically, we cannot see it. Okay, it is how the computer interacts with our data. So, logical data format is how we see the data. Physical data format is how the computer processes or works with our data. Any program that accesses a file system's file must tell the computer not only what to do, but also how to do it. Okay, take note, any program that accesses a file system's file must tell the computer not only what to do, but also how to do it. Okay, so in this diagram, we can see the logical schema, logical data independence, physical schema, physical data independence. So logical schema is the one that we can process or we can view. Physical schema, physical data independence is how the computer works with our data. Okay. Data redundancy. When we say the word redundant, what does it mean? When we say the word redundant, what does it mean? When we say the word redundant, what does it mean? When we say the word redundant, what does it mean? Okay, sorry for that. Redundancy is what? Something gets repeated. Something is um, done over and over or executed repeatedly. Okay. Data redundancy exists when the same data are stored unnecessarily at different places. Meaning to say, we do not need to store that data again, but that data is stored unnecessarily. Uncontrolled data redundancy sets the stage for, number one, for data security. Why? Having multiple copies of data increases the chance for a copy of the data to be susceptible to unauthorized access. Of course, if you multiply a copy of something, let's say for example, you make a cheat list and then you distribute it to your classmates. The more you distribute the cheat list, the greater your chances of what? Getting caught by your teacher. What else? For example, you are in a secret society and you are distributing pamphlet. The more pamphlet that you distribute and the more pamphlet that you give out, the more chances that you will be caught. Okay. Now, data redundancy also leads to data inconsistency. When we say inconsistency or inconsistent, what do we mean? The word inconsistent means that you are or something is objecting to what you are saying. Meaning to say, for example, you are saying that you are innocent, but yet there are evidences that tells the lawyer or the prosecutor that you have indeed committed the crime. So that is inconsistency. What else? You are drawing straight lines. And then after that, all of a sudden, you have drawn a curved line. So that is inconsistent. Okay? Data inconsistency exists when different and conflicting versions of the same data appear in different places. Okay. Now, figure 12, if you look at it, is a table with sample data redundancy. Can you tell me where the data redundancy can be found? Okay. Is it under the column student ID? How about the name? How about contact, college, course, or rank? Okay, as you can see, in the columns college, course, and rank, the data are repeated or there is redundancy of data. The college GEU is repeated, the course BTech is repeated, the rank 1 is repeated. If these are all the same, why not just put a column having one particular value, right? Basically, those three equates to one particular value only. Why not make a unique ID, okay, instead of repeating those three columns? Next, data integrity. When you say integrity, what word comes into your mind? Okay. When you say the word integrity, it means it can be trusted. Okay. It has honor. What else? We are sure that that is correct or that is true. That is integrity. Okay. Data integrity is defined as the condition in which all of the data in the database are consistent with the real-world events and conditions. In other words, data integrity means data are accurate, there are no data inconsistency, and data are verifiable. The data will always yield consistent results. You can verify the data. So that is data integrity. When we say data anomaly, it develops when not all of the required changes in the redundant data are made successfully. The data anomalies found are commonly defined as follows. So there are 1, 2, 3 types of anomalies. Let's first discuss insertion anomaly. Okay. In insertion anomaly, for example, we have a student detail that has to be inserted whose course is not being decided yet, then insertion will not be possible till the time course is decided for the student. So in this example, because the course is yet to be decided, what we do is we insert the data, but we fill or we do not enter any data for the course. So that is insertion anomaly. Why? We inserted the data, but the data is incomplete. The data is not accurate. Okay? The data is missing something, and we cannot verify the data. So that is why this is anomalous. Okay? Next, update anomaly. Suppose if the rank of the college changes, then changes will have to be all over the database, which will be time-consuming and computationally costly. Okay. Now, for update anomaly, this happens when we need to update something. Okay. For example, in this table, As I have said, okay, we have three columns that could already be treated as one, but we separate it into three columns having repeating values. Now, for example, in this example, if the rank of the college changes, let's say from 1 it becomes 3, okay? You need to change all of your data having the rank of 1 under college GEU, okay? Under the course BTech. So it meaning to say, if the rank changes, so from 1 to 3, we need to update all of these data. So we need to update all of the four data. If one of them is not updated, okay, update anomaly happens, meaning your data will not be consistent anymore. Your data is not accurate anymore. You cannot verify that your data is correct. Why? Because we forgot to update one of the columns that needs to be updated. Okay? Lastly, delete or deletion anomaly. If the details of the student in this table are deleted, then the details of college will also get deleted, which should not occur by common sense. This anomaly happens when the deletion of a data record results in losing some unrelated information that was stored as part of the record that was deleted from a table. Okay, so for example, as I have said, because we have separated the college, the course, and the rank into three columns instead of just using one ID, which can be linked to another table. Okay? When we delete a data here, any data, for example, ISU, okay? And then ISU, let's say, for example, you have deleted ISU and then ISU is under a different course, okay? What happens is that the college, the course, and the rank will also get deleted because you have deleted that particular student in your record. So under delete anomaly, because we have deleted that particular information and then some of the information of college are related, we cannot verify if there is indeed that particular course in that college because it got deleted when the record of the student got deleted. So that is where deletion anomaly occurs. So I will prepare other samples so that the samples of anomalies will be clearer to you. Okay.
Hello guys, here we have two tables, table bread and table Pokemon. So for each table, we will be giving an example for insert, update, and delete anomaly. Okay, let's first start with table bread. Now, as you can see, under table bread, I have four columns. I have bread ID, bread name, bread category, and bread flavor. Okay, if we are to give an example about insertion anomaly, take note that insertion anomaly happens when we try to insert data. Okay? When we try to insert an incomplete data, the table should not allow insertion of incomplete data. Okay? Because there is a chance that we cannot trace back or we cannot identify what particular uh, group that data belongs. Let's say, for example, I want to insert another bread. So I'll be giving it an ID of 4. And then let's say, for example, I want to give it a name of Spanish bread. Okay. Now, for example, we do not know the category, but we do know the flavor, which is sweet. So if we will try to take a look at this example, because I have inserted a data, we can identify that that particular bread is Spanish. However, if I try to check what category of that bread, if it's local or foreign bread, I cannot possibly know. Okay? Because I have inserted a blank data. Okay? In order for us to avoid an insertion anomaly, we must make sure that all of the data in our table is complete. Okay? Because all of these columns are interrelated to each other. Now, let's say, for example, we need to update this particular table. Let me fill up the bread category first so that we have consistent table data. So now we will try to do an update anomaly. Okay. Let's say, for example, under our category, you can see that we have two main category, local and foreign bread. Okay. Let's say, for example, we want to update our local bread to have the tag of, instead of local, Pinoy. Okay? So, Pinoy. While doing this, the user forgot to tag, okay, bread number 2, which is tasty. So, what do you think will happen? Okay. This category, local, will now get lost. Okay. There's a possibility that we cannot get the data anymore because we have forgotten to update local into Pinoy. Whereas we should have updated all the data into what? Into Pinoy. All the local data into Pinoy. Okay, so that happens in update anomaly. You must remember that in order for us to avoid update anomaly, all the relevant and pertinent data must be updated. Okay, so this one should also be Pinoy. Okay. The same applies to the bread flavor. Okay. Um, if in case we need to update sweet into the word matamis, okay, we should update all the instances of sweet into the word matamis. Okay. Now, what happens when we try to delete a data and then we try to check if that deletion will result in a delete anomaly? Okay, let's say, for example, because all of the columns here are interrelated, when I try, for example, to delete this particular data number 3, ensaymada, which is a category of foreign and flavor of sweet. Say, for example, I try to delete the data. Okay, so data number 3 has been deleted. However, notice that the category, because we have deleted record number 3, the category of foreign and the flavor sweet has also been deleted. So if we are to check how many categories in our table bread, we are now missing the foreign category. So that instance is an example of a delete anomaly. Because our table columns are interrelated, okay, when we delete a particular data, that data gets lost. Okay? The category gets lost. For example, if we are to do a query or a checking of all the available category in our table bread, it will only result in one category, which is Pinoy. Okay? Because we have not separated the category from the bread. Okay. Now, let's try to do another example using this table, table Pokemon. As you can see, we have four data. Okay. We have four data. Bulbasaur, Charmander, Squirtle, and Pikachu. We have the following element. We have three elements, namely grass, fire, and water. And then we have two regions, Johto and Hoenn. Let's say, for example, I want to insert a new Pokemon. Let's say 5. And then I want to insert uh, Jigglypuff. Okay. Now, Jigglypuff is, let's say Jigglypuff is of grass type. This is just an example. Okay. Now, upon insertion, I do not know the region of Jigglypuff. So what happens? I leave it as blank. Now, this is an example of an insertion anomaly. Why? Because we cannot identify what particular region Jigglypuff belongs. Okay, we have a Pokemon called Jigglypuff. We have an ID number 5, but we have an element of grass, but we do not have a particular region. Okay, so in order for this data to be valid, we must identify the region to which this particular Pokemon belongs. Okay, for example, Owen. Okay. Now, this can also happen when we insert a blank Pokemon element. So that is also an insertion anomaly. Or you could also say that there's an insertion anomaly if we do not provide any Pokemon name, but we provided a Pokemon element. So that is insertion anomaly. Remember that in insertion anomaly, all the pertinent data found in the column must be filled up in order for us to identify that particular data. Okay. Now, let's say, for example, we will try to check for an update anomaly. Let's say grass. Okay. All the data under column Pokemon element having a value of grass must be updated into the word damo. Okay. But we have forgotten to update Pokemon ID number 4. Now, what will happen? Instead of the Pokemon element having only three types, which is Damo, Fire, and Water, we will now have four types. Why? Because you did not update all the instances of the data grass under Pokemon element. Okay? Grass will now be a unique category or a unique data for Pokemon element. Okay? So that is an update anomaly. This can also happen when, for example, in Pokemon region, Johto must be updated into Lawang Bato. Okay, so all instances of Johto must be updated to Lawang Bato. However, you have forgotten to update one Pokemon region under Charmander to Lawang Bato. What happens? What happens is that we now have three region instead of two. So we have Lawang Bato, Johto, and Hoenn region. So that is update anomaly. So in an update anomaly, you must remember that all pertinent data, all related data that should be updated must be updated in order for the data not to get lost. Okay. Last example is delete anomaly. So delete anomaly, let's say for example, we have deleted Squirtle. So remember that Squirtle is a water type under the Hoenn region. So what happens? In this instance, because they are interrelated, the data that we have deleted will not only be Squirtle, but we will also be deleting the category or the data water from Pokemon element and the region Hoenn from the Pokemon region. So basically, all this data are lost, not just Squirtle. Okay? The data for water under Pokemon element and the data for region under Pokemon region will be lost. So we cannot find them anymore because we have deleted them. So there you have it. Those are the samples for insert, update, and delete anomaly. Always remember that these anomalies must be prevented by doing a proper design of our table. And that will be covered in our future lectures. Okay? Thank you.